Hello sir, hello everyone. So this is to me Mr. Prosper. Yeah, a student at Master University of Science and Technology, and I'm doing some assignment on system programming. Yeah, so specifically we are in advanced input-output operations, and specifically for this assignment, so about race condition, like how we can control the race condition. Yeah, for new people, if you don't know something on race condition, uh, it's all about when you have a shared resource that is accessed by more than one process and the output is assumed to be unpredictable. Yeah, like last time we had our lecture, like yeah, we experimented that one and it worked. The output was unpredictable. Like if multiple processes are running at the same time using one resource. Yeah. So the question is here is implement a multi-threaded C program that stimulates a simple resource sharing scenario with mutex and semaphore. Yeah. So these mutex and semaphores, of course, are two fundamental synchronization mechanisms used in concurrent programming to ensure data integrity and prevent race conditions. Yeah. So these two methods are used to control the race conditions. Yeah. Like when multiple threads access that shared resource simultaneously. Yeah. These two methods, they serve the purpose. Yeah. Coordinate. They serve a great purpose, of course. Yeah. Like when you're using a mutex, like something you should know about mutex. Yeah, like when you lock a resource for a process, it's why you lock a resource for a process or a thread to access it. Then after using it, you unlock it, and then another process can access the CPU for the same functionality. Then sem for semaphore, like for it, yeah, it is a synchronization tool, of course, that regulates the access to multiple resources by maintaining a non-negative integer count. So for mutex, of course, it is a synchronization primitive that restricts access to a shared resource to only one thread at a time. Yeah, so for mutex, it allows one thread at a time, but for semaphore, it can allow multiple resources, yeah, at the same time. Of course, there are many differences between these two methods. But specifically, if like for us to continue with this question, it is telling us to implement a multi-threaded C program that simulates a simple resource sharing scenario using mutex and SIM. Yeah. So to start with that, of course, you need to go to your, of course, your Linux. For me, I have it as a subsystem. Then use your touch command to create a C file. Like you can create something like counter. Then of course you need to add that extension .c. For you, after running this, it will have to create some file. So after you pressing enter, of course you need to go to your Linux. Then you identify where your file has been created. Then mine is at home. Specify this directory, then advanced input outputs, then it is in exercise. Yeah, then it is here counter 3. So mine, I called it counter 3. Yeah. So basically this is my program. So this is a C program. Of course you need to be having some background on how you can run these C programs. That include which include so basically you should be able to know those C programs, like for you to execute these commands. Yeah. So specifically, uh my program that will implement the mutex, which is our mutual exclusive program. Yeah, so to get some explanation on this code, of course there are many new variables here. I try to define like what each line can do in this code. Maybe you can read through and maybe understand. But for me to give you some basic, like the overall explanation of this code, yeah. So basically, this program creates three types of threads, which is incrementer, decrementer, and observer. And each thread performs a certain operation on a shared variable called counter, which represents the resource. Yeah. So this program also uses the mutex to synchronize the access to the counter so that only one thread can modify or read it at a time. Yeah. So basically, of course, these are functions. These are basic functions in C. This is how you can create. Yeah, here you have created some incrementer. You also have to create a decrementer somewhere, and also, yeah, and also create a function for observer. Yeah. So this program, of course, will print the current value of the counter after each operation. Yeah. So this is how it will be. It will be able to print the current value of the counter after each operation. Then the program also demonstrates how mutex and can prevent data inconsistency and can okay can prevent data inconsistency and race conditions that may occur when multiple threads try to access the same resource concurrently. Yeah. So basically, this our program will be able specifically to do something like that. So even this program includes standard input output library. Of course, these are the libraries which you find up. Of course, the standard input, the standard library, and the POSIX libraries. Yeah. So the program also defines a global variable counter, yeah, to represent the shared resource, and global mutex synchronize it. The program also defines three threads: incrementer, decrementer, and the observer. Yeah. Whereby the incrementer increments the thread by one, and the decrementer decrements, of course, yeah, the incrementer, of course, will be able to decrement the counter by one, and the observer then will be able to print the current value of the counter. And even each thread function, yeah, these are functions. Yeah, so each thread function repeats a certain number of times and acquires and releases the mutex before and after accessing. Yeah, so after accessing, of course, you will be able to release the mutex, yeah, which is this one, something like this. After using the mutex, you'll be able to release it so that other processes can also access it. Yeah, basically this p thread, the mutex unlock. Yeah, after using, you have to unlock something. Yeah, of course, each thread function also exits the thread when it is done. Yeah, so after the process, after the process after the process using the is done with using the resource, yeah, so you'll be able to exit that thread when it is done. So this is the best code I try to explain, at least for each and every. So this is the main function. Yeah, here the main function. So this main function of the program will be able to initialize the mutex, declares three variables, creates the three threads, waits for the threads to finish, destroy them, and returns the main function. So specifically, this main function that will be the basic operation that you'll be able to do. Yeah. So the main function also passes the thread functions and arguments to the thread creation function. The main function, of course, we also joins the thread to ensure that they are completed before the main function exits. Yeah. Of course, the main function does not pass any arguments to the thread functions and does not receive any return values from them. Yeah. So the main function, of course, at the last we have uses the null pointer to indicate the absence of argument and return values. Yeah. So basically, that's how I can maybe explain how this code operates. Yeah. Since I tried to put some comments on how each line on okay, like basically on how each line, it's the basic importance of each line in this code. Yeah. So of course, if you don't know C, this will be some kind of hard for you to understand. Maybe you need to go back and watch some tutorials on C programming. Yeah. So this is my program, and I will try running it, of course. So for me, I used the dev C++ to act as my IDE. It's why I opened after creating the document from Ubuntu. So I opened it. I opened it with this dev C++. So for me, after doing all this, of course, you save with Control S. Then after saving, of course, you need to go to Ubuntu something. Yeah. After, of course, now we are done with this. So if you press LS, you see that we have counter 3. It is created already. Of course, so for it to run, to run, of course, you need to first compile before running. And for you to compile, it is gcc, then the C program name, which is counter 3. Then afterwards, of course, you give it a name. You give it its name, because if it is not given, the output will be stored in a.out, of which you don't want .down. So we shall give it something like counter 3 something. So after doing this, of course, you run. Yeah, then you see, yeah, it has some errors, but it can be run from there. So if you press ls, of course, it will be able to create some other executable file, which is counter 3. So of course, now we shall run this executable file which it has created using the / then counter. Yeah. So basically, this is our yeah. This is what our code does basically. It first increments from 1 to 10. Then the observer, of course, will be able to read up. We read from here. Then it again decrements from 10 then to 0, and the observer will be able to read even the last point here. So the observer will be able to read the middle point and the minimum point. Yeah. So this is my code to implement using the mutex. Which or which you can call the mutual exclusive. Yeah. So all these requirements are in what I have done the other side in our code. Yeah, whereby implement a program that includes 3 threads, increment and decrement observer. The increment of the thread should increment the counter, the decrement thread should decrement the counter. the observer thread should predictably print the value, yeah, of which you have done the other side. Yeah, then use mutex to synchronize the shared counter. Uh, so this is specifically what you are supposed to do. Uh, so we can also implement the same thing using the semaphore. Yeah, it is possible. You can use the semaphore to do the other things. They can do the same thing. Yeah. Of course, there are some differences. Like there are some key differences of like mutex enforce exclusion access, allowing only one thread to hold the text at a time. While the semaphores, of course, on the other hand, allows multiple threads to acquire the resource up to a specific limit. Yeah. Of course, if you are also if you can consider the counting difference, the mutex are binary, representing either locked or unlocked states, while the semaphores maintain an integer count, allowing for only a granular control over resource access. If you are to consider the application, for mutex, they are primarily used for protecting, of course, critical sections of code, uh, where data integrity is paramount. Then for semaphores are typically employed to manage access to limited resources and prevent resource contention. Yeah. So maybe you can also try again to implement the same thing using the uh, using the semaphore. Yeah. Uh, so of course you need to follow the same procedures, like if you want to create something like that. Let me first clear the screen. So of course here you need to also begin something with that something, then you give it a name, something like semaphore. Yeah, semaphore, then you give it that extension .c. Yeah, so if you press enter, this file will be created the other side. So you need to go to your files and check whether if you look here, you see our C program has been created. So if you try to open it, it's like I already have the code, yeah, to be able to write all this code, like when you're explaining. So this is the basic. This is the basic. This is how you can implement. Uh, this is how you can implement, of course, using the semaphore. Yeah. So you also, of course, do the same like the other side. You consider the counters. You consider what. Uh, yeah. Here you need to be sure, of course, what you are doing. You can jump from nowhere. You need to be having some idea. Yeah. So specifically, this code, like, shows how to use the semaphore to synchronize access to shared counter among the three threads. Yeah. So the semaphore is initialized with counter of 1. Yeah, something like that. It will be initialized with a counter of 1, which means that only one thread can access the counter at a time. Yeah. So maybe that is its specific use. It is initialized with counter 1 so that only one thread can access the counter at a time. Also, the semaphore, of course, ensures that the threads wait and signal each other before and after accessing the counter, and prevents data inconsistency and rest conditions. Yeah. So basically, this is the basic use of semaphore. the basic implementation. You need to also create these functions in C. Of course, you need to be having that basic knowledge. Of course, after these are basic functions. These are basic functions in C which are created, and the for loops, the what, and then they're implemented using the semaphore. Of course, you have seen it up that it has its own library. You can't use these statements like same dash weight minus using the other library which I've created up the same, yeah, this library, the semaphore.h. So you need to have also consider that library too. You can also experiment, of course, with different semaphore counts to control the access to shared resources. For example, like if you initialize the semaphore with a counter of 2, then two threads can access the counter at the same time. Uh, this may result, of course, in different outputs depending on the order of execution of the threads. Like the counter alternates between 0 and 1, and the observer, of course, always sees 0. This is because, of course, the incrementer and the decrementer are running concurrently and cancelling of each other. Yeah. So of course you need to be having this basic information also. You need to, yeah. So it means the counter like should be able to be 1. If it becomes something like 3 or 2, yeah, it may result your code being like its output may result be something like it is unpredictable. Yeah. So basically this is the basic information that you should know about these two methods, yeah, which are used basically to control the race condition. Yeah. As we have said before, race conditions which is brought about like when you have a shared resource that is accessed by more than one process, which brings about the output being unpredictable. Yeah. So basically this, maybe if you are to run this code and see its output, it's also possible. You go to your Ubuntu, which I'm having here as my Windows subsystem. Then of course if you press ls, yeah, be having it will be there. So for you to compile, you need to be having to use the gcc, then semaphore, then you give it a name, which is by using minus o, then specify exactly the name you want to give to your file. Then if you press enter, it will be able to create some executable file. Yeah, it will be there something like semaphore. Yeah. So this file will be having permissions for you to run. Yeah. So for you to run, you need to use the dot slash, then the semaphore. Yeah. Yeah. So basically, yeah, it does same thing like the mutex. Yeah. It increments from 1 to 10. Then of course the observer will read at the maximum and again read at the minimum. It increments, yeah, and again it decrements, then the observer reads that thing. Yeah. So let me hope I have answered all the questions. Yeah, so I think this is the best I can explain this assignment. Yeah, thanks for everyone for viewing my presentation. Yeah, and thank you.